A little bit harder now. We've gone to negative and fractional powers. Well, if you think about something like, I don't know, root 3 times root 3, you should know is 3. Well, 3 is 3 to the 1. So, what powers would these have to be? They must be the same, and they must add up to 1. Therefore, it can only be a half. What that tells us is square root symbol, the radical, means power half. Now, you just need to be careful here, just a bit of notation for you. If x squared equals 9, then x can be 3 or minus 3. But were we to say square root 9 like that, the answer is 3 only, because that symbol means the positive square root. If you wanted the answer to be, well, let's go from here, x squared equals 9. We'd write x equals plus or minus square root 9, which is plus or minus 3. That's why you have the plus minus symbol in the quadratic formula. So, you can extend this further as well. If we add, say, 4 to the third times 4 to the third times 4 to the third, when you add up the powers, a third plus a third plus a third is 1. So what times by itself 3 times is itself? Well, that's cube root. So we know power third means cube root. Okay, you can take that forward. If we have x to the 1 over a, say, that will be the 8th root of x. If you've got x to the m over n, well, this is going to be the nth root, then power m. Now, whenever you're doing numbers, always do the square root, cube root, fourth root first, because you're reducing down the numbers, rather than applying this power first. Otherwise, you're going to get a really big number and then square rooting it, cube root, you don't have a clue. So, do that bit first. Negative power, we'll just flip it. Anything to power naught is 1. Okay, so we're going to be using a combination of those rules to answer the next few examples. So on to example 9. We've got an a x cubed divided by x to the minus 3. Well, going back to the division rule, when you've got the same power, same base, you subtract the powers. 3 minus minus 3. 6b. X to the half times x to the 3 over 2. We're using the multiplication rule. When you're at the same base, you add the powers when they're being multiplied. So half plus 3 over 2, 1 half plus 3 halves is 4 halves. 4 divided by 2 is 2. X squared. C. X to the cubed for 2/3. Remember from the first rules we had, when you've got powers separated by brackets, just multiply them together. 3 lots of 2/3 is 6/3, which again is 2, or 3 and 3 just cancel. It's x squared again. D. We've got the cube root 125 x to the 6. Now this cube root applies to both 125 and x to the 6, so we can split it up and make it 125 to the power of a third and x to the 6 to the power of a third. The cube root of 125, what times by itself? 3 times is 125. What's 5? 5 times 5 times 5 is 125. Power separated by brackets, we times them together. 6 lots of 1/3 is 6/3, 6 over 3 is 2. 5x squared. E. No, that was E. I missed D. Let's do D now. That was E. We've got 2x to the 1.5 divided by, well, it's shown as a divide by symbol, but I'll do underneath 4x to the minus minus 0.25. Well, firstly, 2 divided by 4 is a half. And then 1.5 minus divides, so we take the powers away. 1.5 minus becomes plus. 1.5 plus 0.25 is 1.75. Sure why that one uses decimals. Normally leave them as fractions. F 2x squared minus x over x to the 5. If you remember from before, we split up each part of the numerator and divide it separately by the denominator. So that's 2x to the minus 3, because 2 take away 5 is minus 3. I mean, you could write that one as 2 over x cubed and do 5 take away 2 is 3 and then leave that on the bottom. It doesn't matter, there's no difference. And then here, 1 minus 5 is minus 4. Okay, we could do 5 take away 1 is 4 and then leave that on the bottom. I mean, either answer's fine. It didn't say in the question how it wanted it to be read, so either's okay. Example 10. Evaluate means find the value of 9 to the half. So positive square root of 9 is 3. 64 to the third. Cube root of 64 is 4. 4 times 4 times 4 is 64. So it's a bit harder. 49 to the 3 over 2. What we're going to do is split that power up and make it 49 to the half cubed. Because this reduces the number down. There is no non-calculator paper element to the A-level exam, but you still should be able to do this in your head without a calculator. So square root of 49 is 7. 7 cubed. So that's 3, 4, 3, I think. Yeah, I think so. So 25 to the minus 3 over 2. Well, first let's make the power positive by flipping it. So it's 1 over 25 to 3 over 2. Again, I'm going to split that up into the half cubed. So 25 to the half is square root of 25, which is 5. 5 cubed is 125. And to example 11. So y equals 1/16 x squared, which you can think of x squared over 16. Either of these is fine. We need to work out what y to the half is. So effectively we've got to square root every element of this. So it's going to be 1 to the half, 16 to the half, x squared to the half. Well, square root of 1 is 1, square root of 16 is 4, times the powers together, 2 times a half is 1. So it's just a quarter x. Or x over 4, same thing. B wants 4y to the minus 1. Okay, let's work out y to the minus 1 first. If y equals x squared over 16, then to get y to the minus 1, we just flip this. 16 over x squared. And times by 4, 4 lots of it, 4y to the minus 1, 16 times 4, 32, 64. 64 over x squared, or 64x to the minus 2. Okay. It said it wanted it in the form of kx to the n. So, yeah, we should write it as 64x to the minus 2. There we go, to exercise 1D now. Get on my nose.